So now we're to our third and final part of 1.4, graphing lines. So first we just kind of graphed some simple lines, and then we kind of looked at what slope of a line is. So now that has prepared us for graphing lines by using slope-intercept form. So this right here, y equals mx plus b. Hopefully we're familiar with that. If not, here we go. We're going to go over it. Uh, M is going to represent your slope, okay, and B is going to represent the y-intercept. So if you think about this, the definition of y-intercept is to let x equal 0. So if you let x equal 0, this is going to get canceled out because the 0 will cause, doesn't really matter what the slope is, right? 0 times anything is 0, and so you'd be left with y equals that B value right there. So that B value gives you your y-intercept. When graphing the line, B is going to tell us where to begin. So that will be our first point, will be the y-intercept. And then the M value will tell us how to move. And by that, I mean rise over run. Okay, so let's go ahead and look at these first couple. They're all in slope-intercept form. Eventually, they may not be in slope-intercept form, and we'll have to adjust them. But all these first couple that we're going to look at, they're all in that format right there. So the slope is the value, is the coefficient in front of x, so it's 2/3. So don't take the x with it. That's a common mistake students will make. So the x is not part of the slope. That's the variable. The y-intercept would be at 0, -1, because if I let x equal 0, y is going to equal that -1 or -1. Okay, so we'll go ahead and begin by graphing that first point, 0, -1, and then my slope is 2/3, so we're going to do rise over run. So basically it's change in x over change in y. So I'm sorry, I said that backwards, the change in y over the change in x. So the change in y is increased by 2, and then x increases by 3. And you can continue this pattern out if you want to, just to find an additional point. So let's see, up 2/3. And so there we go. And when you're doing your homework, you'll have a line tool, and you'll just plot 2 of the points, and then the line will actually just go ahead and show up on the whole graph. Shouldn't be too difficult. And so that line represents all the ordered pairs that would satisfy our equation up here. So if you plug in any of these ordered pairs, even the decimals, those, if you plug them in, the two sides of the equation will be balanced. Okay, looking at our next one, we have y equals -1/2 x plus 4. So I'm going to go ahead and put the negative with the 1. It's personal preference. If you want to, you can put it with the 2, but I like to put it with the numerator. Then let's see, the y-intercept would be at 0, 4. And so that's where we're going to start. Now remember, this is the change in y over the change in x. And that triangle is short in math for change. Okay, so the change in y, it's -1, so it's going to decrease by 1. And then the change in x is +2, so I go over 2. Down 1/2. Now, let's say that I put the negative on bottom. Let's say that I put the negative with the 2. Well, then the change in y would be to go up 1, and the change in x would be to decrease by 2. And so you see it still lines up all in a row, okay? And so we'll go ahead and plot those points right there. And there's our line. Put arrows on the end. That just indicates that the line goes in each direction indefinitely. Okay, on number 9, this time our slope is 3, and our y-intercept is going to be at 0, -2. So we'll go ahead and plot 0, -2. Now, my slope this time is -3, and so you're like, well, how do I do rise over run? Well, just put it as 3/1. Same thing as 3, so then we can go ahead and rise up 3, run 1. Rise up 3, run 1. And we'll go ahead and plot our line. Okay, and there we go. All right. Moving on down. Okay, kind of more of the same. So here, let's see, I have y equals negative x minus 3. So that's an understood negative 1 in front. So that's my slope, negative 1. And then my y-intercept, if I let x equal 0, then y is going to equal negative 3. So we'll go ahead and plot that. And then my slope is negative 1, or I can look at it as negative 1 over positive 1. Once again, I could put the negative on bottom if I really want. So the change in y over the change in x. So I'm going to go down 1, forward 1. Down 1, forward 1. And then we'll go ahead and connect those. And there we go. All right. So looking at number 11, I have x equals 3. Well, that's interesting. There's an x, there is no y value, right? That's weird. So what's going on here is this is a special case of a line. It actually is going to create a vertical line. So the way you could kind of think about this is you could have plus y times 0. So if you were to make a table of values for x and y, so, if y were to be, 2, well, 2 times 0, that's just going to keep getting knocked out, and x is just going to be 3. So whatever you plug in for y, whether, negative 5, well, x is still going to be 3. So basically what happens here is x is just 3 no matter what. Well, where's x equal to 3? Right here, right? That's where on the x-axis x equals 3. So x is 3 here, 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 all these points, right? The decimals for the y value. So the x value is always staying 3. Y can be whatever you want it to be, but x is always at 3, and so it creates that vertical line right there. So the slope would be undefined. The y-intercept, I actually don't have one. It doesn't actually cross the y-axis in this particular case. And then if you look at 12, 12 is kind of similar, except this one will probably have a little better feel for. You have y equals 0 times x and then minus 2. So you can kind of see that the slope is 0 right there. Okay. And then your y-intercept is at 0, negative 2. Okay. And so, you should know that a zero slope is just a flat line. So if you want to, you can draw your flat line. Just remember on your homework, you'll have to plot 2 points in order for that line to pop up. So I'll go ahead and put 2 points there and just connect that. And there we go. We have a flat line. So if you have x equals, you're going to have a vertical line. If you have y equals just a single value, it's going to be a horizontal line. And so all the y values are negative 2, or in the first example, all the x values were 3 right here. All right, we're going to try a couple where they are not in slope-intercept form to begin. Here we go. Okay, so it says rewrite the following in slope-intercept form. Basically, we want to solve for y. Then next, use the slope and y-intercept to graph, just like we did on the previous page. So if you look at problem 13, you're like, oh, the slope's 2. Not quite, okay? You have to have it in slope-intercept form before you can do that. So you have to make it look like y equals mx plus b. We have to have it in that format. So I like to draw a line to differentiate the two sides, just kind of keep things organized. So what I'm going to do here is I'm going to subtract 2x from both sides. So subtract 2x, and so that will cancel out. I'm going to be left with y equals, now I have 6 minus 2x. What I like to do is I want to put that minus 2x first, and then that positive 6, I'll just tack it on as a plus 6. It's just personal preference. I want to make it look like the formula we're used to. If you really want to write it as 6 minus 2x, that's fine too. Just, make sure you know which one's your slope and which one's the y-intercept. So you just kind of have to be careful. So moving forward, I'm going to put it in this format right here to make it look like what we're used to. But, if you write it this way, the computer's not going to count it wrong or anything like that. So our slope is -2, and I'll put a 1 under it. And then our y-intercept is 6. So we're going to start up here at 6. So I'm going to go down 2 over 1. Down 2 over 1. I could keep doing that if I want to, but really once you have a couple points, you're good to go. And there we go. Okay. All right, looking at 14, it almost is there, but except I have negative y, I need a positive y. So what I'm going to do is I'm going to divide everything by -1, and that'll just cause a sign change everywhere. So y equals -3x and then -2. Okay, and so let's see, our slope is -3 or -3 over 1. My y-intercept is at 0, -2. All right, so we'll go ahead and plot that right here. And then let's see, make sure I got plenty of room. So let's see, down 1, 2, 3 over 1. Or if I wanted to, I could go in the reverse. I could go up 3 and then go backwards 1. So I could kind of flip it and put the negative on bottom if I really wanted to, if I didn't have enough space. And that should be good enough. And we'll go ahead and put our arrows, and there we go. Okay, I got 2 left for us here. Okay, so on this first one, let's see, I've got 5x minus 3y equals -12. So got a couple steps involved here. So the first thing I'll do is I'll isolate the y to one side. So I'm going to subtract 5x from both sides. So that cancels out. Now be careful, I'm left with -3y. You don't want to forget to bring the minus with you. And then I'm gonna, once again, I'm gonna kind of tuck the first value behind my slope and my x variable. So I'm gonna write this as -5x, and then I'm gonna put the -12. Then what we'll do is we'll divide everything by -3, and I should be good to go. So that cancels out. So we get y equals, double negatives cancel out. So I'm going to get 5/3 x, double negatives. So this will become +4. So 3 divides into 12 evenly. And then with the -5 and -3, all I was able to do is cancel out the double negatives. So I'm going to start at my y-intercept, which is up here at 4. And then my slope is 5/3, so up 5 over 3. That's going to take me off the graph quite a bit. So let me show you a little trick here. So my slope, and when you're doing your homework, this shouldn't be a problem. The graphs are going to be bigger, okay? So what I'm going to do here, isn't 5 over 3 the same thing as -5 over -3? And we actually know that from when we simplified it. And you definitely do want to simplify it and make it positive. But it also could be written as -5 over -3. And so what that's going to help me do is find my other point by dropping down 5 and going backwards 3. So dropping down 1, 2, 3, 4, 5, and going backwards 1, 2, 3. And that puts me right there. And so if I would have gone up 5 and over 3, I'd probably be somewhere over here, right? So they all would line up. So either way, it should work out fine. And like I said, when you're doing your homework, your graph size will be bigger to where you won't have any issues like that. Put our arrows on the end, and that one looks good. All right, so our last one, here we are. X take away 2y equals 0. So I'm going to start by isolating the y again. So I'm going to subtract by x on both sides. So that cancels out. So -2y equals -x. And then I'm going to divide both sides by -2. So we'll cancel that out. So we're going to have y equals, so you have double negatives. So if you want to leave it as x over 2, that's fine. Most people would probably prefer to write it as y equals 1/2 x, just because it makes it a little bit easier to know what your slope is. Okay, so our slope is 1/2. Okay, Now you might be thinking, okay, well, what's the y-intercept? Well, basically, you have a +0 back here, which is extra information. That's why we don't include it. But you basically have, if you let x equal 0, y is going to equal 0, right? So right here is where we start at the origin, and then we'll go ahead and apply our slope up 1 over 2. Up 1 over 2. Do that a couple times. We'll go ahead and put our line here. Straighten it out just a little bit. And there we go. So that's graphing lines part 3. And so next we're going to continue with lines, but it's going to be a little bit more algebraic properties that we're going to look at. And so it's not going to be so much graphing, it's going to be other things. So, all right.